This is lesson 6 of the Matrix unit, exercise 5G, communications and connections. Yesterday with Miss Miller, you would have gone through matrix multiplication in different contexts of applications of matrix multiplication. And this is going to be more focused on how connections and links can be represented through matrices. So, social networks, communication pathways, and connections can be represented and analyzed using the previous matrix techniques that we've learned. Communication matrices are always squares. It's a very important fact to remember. Communication matrices are always squares. So, in other words, the order of communication matrices are always going to be a 2 by 2, 3 by 3, 4 by 4, 5 by 5, etc. Okay. The matrix methods of investigating communications can be applied to such things as friendships, travel between towns, other two-way types of connections. I know that you can also do delivery routes, friendship algorithms, especially like social networking platforms like Facebook and Twitter, Instagram, use a very, very complicated way of friendship connections. Very, very interesting stuff. So this diagram that we're going to look at now, right here, it shows the communications within a group of friends. So there's 4 people: Vicky, Stephen, Kathy, and Paul. The 2 notes you want to see here, the double-headed arrow connecting the 2 names, that indicates that the 2 people communicate with each other. And the other thing you need to know is that if there is no arrow directly connecting 2 people, they do not communicate. So in this instance, Vicky can communicate with Kathy and vice versa. Vicky can communicate with Stephen and vice versa. But in this case, Vicky does not communicate with Paul because there's no arrow. Okay. So these links are called one-step connections because there is just one direct step in making contact with the other person. So we're going to record the social links using the matrix capital N, using the first letter of each name to label the columns and rows. And we're going to explain how this matrix should be read. So this document can be accessed on Compass. But what you're going to do is underneath A, you're going to copy this matrix down. The V, S, K, and P represent the people. And it's also going to be replicated on the top. We're showing the connections from the set of people to the set of people. Okay. So reading the rows across to column K, this indicates that Stephen can communicate to Kathy. Okay. 0 is used when there's no communication. You'll notice that a communication obviously does not happen with yourself. So V to V, Vicky to Vicky, 0, S to S, 0, K to K, 0, and P to P, 0. You will see a diagonal of zeros with this communication. And all you're going to do is, if there's a communication, you just put a number 1 there. So pretty simple. You will see a mirror image along the diagonal. Okay. And that leads to B, explaining why there is symmetry about the leading diagonal of the matrix. Because the communication is two-way. Vicky can talk to Stephen, and also Stephen can talk to Vicky. So in other words, Vicky can talk to Stephen here, so there's going to be 1. But also Stephen can talk to Vicky, so there's also 1. So this is mirror here. Okay. There will be symmetry, assuming that you put these names down in the same order vertically as you do horizontally. If you flip the orders around or you change them and they don't they're not written in the same order, you won't necessarily get symmetry in the diagram. Okay, so it's very important that you make sure that you write it in the same order. Okay, once you've written it down, we'll go to the next step. You can always pause this if you still need a bit of time. C here and D. I'll scroll this down. Hopefully we have a little bit of room. Okay. So what information is given by the sum of a column or row? So the sum of rows with columns just gives the total number of people that a person can communicate with. So Kathy communicates with 3 people. So if you were to add up the row of Kathy, or the column of Kathy, that will end up being 3. Obviously, Kathy does not talk to herself, so there is a 0. So when you add 1, or the 3 ones and the 0, you get a total of 3. D, this question here, n to the power 2, or n squared, gives the number of 2-step communications between people. Namely, how many ways one person can communicate with someone via another person. Find the matrix n squared, or in other words, the square of matrix n, which is n times n. So this is saying that we want to see how you can talk to people via another person. And you'll notice that the diagonals here will change. Okay, they will change. This is because Vicky can talk to herself via another person in 2 ways. So I'll quickly go up. I will go back down. Didn't have enough time to copy that. As you can see here, Vicky can talk to Kathy, and then back to Vicky again. So this is a 2-step connection because there's 1, 2. Okay, because there's a 2-step connection. This is one way, but there's also another way. Vicky can talk to Stephen, and then back to Vicky herself. So there's 2 ways. Okay, there's 2 ways, or 2-step connections. Two-step connections from Vicky to herself. Then also with Vicky to Stephen, there's only one way via another person. Vicky to K and P, so Vicky to Kathy and Vicky to Paul. Kathy 1 way and then Paul 2 ways. Okay, so that's what 2-step connection means, and that's simply done by scoring. Okay, E and F, go ahead and copy these down. E says use the matrix n squared to find the number of 2-step ways Kathy can communicate with Stephen, and write these connections. So before, when we wrote this down, we know that between Kathy to Stephen via another person, there are 2 ways. Okay, Kathy can talk to Stephen via Paul, or Kathy can talk to Stephen via Vicky. Okay, so those are the 2 ways. Go ahead and copy that down. And F says that in the matrix n squared, or in the n squared matrix, sorry, there is a 3 where the S row meets the S column. This indicates that there are 3 2-step communications Stephen can have with himself. Explain how this can be given a sensible interpretation. So 3 ways that Stephen can communicate with himself. There's Stephen to Vicky, back to Stephen. There's Stephen to Kathy, back to Stephen. And Stephen to Paul, back to Stephen. So an example is Stephen might ring Vicky and ask her to ring back later. That's a sensible interpretation. Okay. You can always pause the video or rewind it back if you don't if you didn't get that down. G. If you were asked to find n cubed or n to the power 3 or n times n, what would this mean? How would you interpret this? Well, if n is 1 step, n squared is 2 step, then n cubed will indicate 3-step communication. So there are ways that you can communicate with someone via 2 other people. Okay. We're not going to do anything or any calculations in that regard. It's just asking what that means. Now, the book says to read column first, but it should be row first. From to. Okay, so just be careful that the from is always on the left and to is on the top. And that concludes lesson 6, exercise 5G. Check your logbook to see which questions you need to do for 5G.